Hello everyone, this is Professor James Won-gi Hong from the Department of Computer Science and Engineering at Pohang University of Science and Technology, POSTECH. In this lecture, I will introduce the networking technologies used in IoT. I would like to thank Professor Youngju Seo, who is an expert in wireless and mobile networking in the same department, for helping me making the lecture slides on this topic. In this lecture, I will introduce key networking technologies used in Internet of Things. I will first compare the wired and wireless networks. I will then explain the most widely used wireless networks, namely cellular networks, Wi-Fi, Zigbee, Bluetooth, RFID, and NFC, near-field communication. The networks are largely divided into wired and wireless. In a wired network, devices are connected to wires and are fixed. That is, the devices usually do not move. An IP camera connected to Ethernet network would be a good example. In a wireless network, devices are not connected to any wires, but they communicate using wireless networking technologies. They typically are mobile devices, such as our smartphones and smartwatches. Wi-Fi, Bluetooth, and Zigbee are examples of wireless networks. Although most IoT devices may be installed and are not mobile because they have limited resources, using wired network for communication may not be suitable. Rather, light wireless networking technologies are more suitable for IoT communications. Therefore, we will focus more on wireless networks in this lecture. We can classify wireless networks differently, but a common way to classify them are according to the distance coverage. The coverage can be identified by the extent to which the base station can send signals and communicate. As for the smallest coverage, it can communicate approximately up to 10 meters. And we call it personal area network. When it is wireless, we call it wireless personal area network, or WPAN. WPAN has various wireless communication technologies such as Bluetooth, Zigbee, and NFC. For a slightly broader coverage, you can use a wireless local area network, or wireless LAN. Wi-Fi is the most widely used wireless LAN technology, with a coverage of approximately up to 100 meters. The IEEE 802.11 has defined a number of Wi-Fi standards over the years. Compared to the first one developed in 1997, the coverage and bandwidth have increased considerably. IEEE 802.16, or WiMAX, is a networking technology for wireless metropolitan area network, WMAN. It typically covers up to a few kilometers. Its coverage is wider than wireless LAN but narrower coverage than cellular networks. In early 2000s, KT and SKT have deployed the Korean version of WiMAX called Wibro. It was a competing technology against LTE, long-term evolution. Unfortunately, LTE won the war, and Wibro is not being used that much anymore. It is being used to provide uplink communications in buses and taxis. The last one is called Wireless Wide Area Network, or WWAN, and cellular networks such as 2G, 3G, 4G, and 5G networks are examples of wireless WAN. These are the communication technologies that our mobile phones use to do voice as well as data communications. Now, I'll briefly introduce cellular networks. As you may already know, the cellular networks have gone through several generations. First generation, 1G, second, 2G, third, 3G, and fourth generation, 4G. Now, it is time for preparing the fifth generation, 5G, of cellular networks. So the LTE phone that you're using now is a 4G phone. Looking at the history of cellular phones, the first generation phone was analog and circuit switching was used with only voice communication possible. The main change in the second generation was a change to digital signals used instead of analog signals. Changing the analog to digital has a significant meaning. So the digital communication has begun from here. In 3G, problems arose when an optimized network of telephone lines called circuit switching is used for data communications, in addition to voice. In this way, there was a lot of waste. So it can be changed to the data packet switching way to be optimized for data rather than circuit switched, naturally optimized for voice as the data traffic increased. So packet switching was used instead of circuit switching in 3G. And we can say that it could be a real digital generation from second generation. And it was all digital after second generation, but it has been used in the packet switched way, away from the third generation. The packet switched is a form of data communication that is increasingly evolving in a packet switched way, as there are increasingly applications sending and receiving data rather than voice. This is also true for the wired network. In a wired network, the public switched telephone network was gradually replaced by the data network. The wireless has also evolved like this way as well. Now, as we are living in the 4G era, known as LTE or LTE Advanced, the difference between the third generation and the fourth generation is that the data speed is greatly improved. If you look at the pictures at the time, you can see that it shows that the phone was evolved in the first generation. The first generation phones were bigger tremendously to the radius in size. Now a very small and smartphone is being used. Then, as you can see on the right, smart pads are also used. They are optimized for data rather than voice, like smart pads on the right. 5G is being standardized and developed. The first implementation of 5G will be demonstrated by Korea Telecom at 2018 Pyeongchang Winter Olympic Games in Korea. Now I'll give you a more detailed explanation on Wi-Fi IEEE 802.11 standards. Wi-Fi is the most popular wireless LAN technology used by devices that people use, such as smartphones, smart pads, laptops. As I mentioned before, Wi-Fi is used for short-range local communication, such as at home, in schools, offices, cafes, train stations, airports, etc. Wi-Fi can be privately purchased and installed in private homes and buildings, but they can also be provided in public places by telcos. Example, KT, SKT, LG Plus in Korea. Wi-Fi operates on unlicensed bands called ISM bands. The industrial, scientific, and medical ISM radio bands are portions of the radio spectrum reserved internationally for the use of radio frequency energy for industrial, scientific, and medical purposes other than telecommunications. Unlicensed bands mean those bands can be used by any device for any application legally. Licensed bands, for those bands that are sold by the government, typically to telcos for specific communication purposes, 2G, 3G, 4G, cellular communications, for example. Telcos pay a lot of money, more than $1 billion for a band, for example, so that they can use that band to do the business, that is, provide communication services, without any interference. Like I said, Wi-Fi networks use unlicensed bands. 2.4 gigahertz band and 5G gigahertz band are popular ISM bands that are used by Wi-Fi. There are two modes of operation for Wi-Fi: an infrastructure network mode and ad hoc network mode. I will explain more about these in the next page. The infrastructure mode is the mode that is most familiar to you. A Wi-Fi access point is called a base station. After buying an Wi-Fi wireless LAN hub or base station, you can connect the base station to internet by connecting it to a communication port in your home router provided by an internet service provider such as KT, LG Plus, or SK Broadband in Korea. In other words, you can think of the infrastructure mode as the base station. Even if there are hundreds of terminals under the same base station, they cannot communicate with each other directly, but only through the base station. The base station is connected to the internet. We call this the infrastructure mode. You can understand the notion that it's connected to communication infrastructure, and it is used as it is. We call that mode on the right as ad hoc mode. There is no base station here, so because there is no such controller, terminals need to communicate directly with each other. However, it should be within the communication distance. If it is too far away, obviously communication will not be possible. So the difference between the infrastructure and the ad hoc mode is that there is a one hop to go to the wired network in the infrastructure mode, but maybe many hops in the ad hoc mode. When it comes to the hop, we call it as a hop when we count how many devices you need to connect wirelessly. Since only the terminal and the base station are connected with wireless, it's called a single hop. Look at the right side. When a terminal communicates with other terminals, there might be a case that you have to communicate through several hops. This is called a multi-hop communication. I will give you more detail in the next page. As illustrated in the diagram, Wi-Fi mostly operates using an infrastructure mode. Like I have previously explained about the infrastructure network mode, there is a base station and the terminals communicate each other through a base station. When you configure your wireless access device, you notice a field called Service Set ID or SSID. You must configure all connecting devices and access points in a service set to use the same SSID. The two types of services sets are Basic Service Set, BSS, and Extended Service Set, ESS. A BSS consists of a group of terminal devices and one access point, which links to a wired local area network. An ESS consists of more than one AP. And ESS lets mobile users roam anywhere within the area covered by multiple APs. BSS is connected to the wired network called the distribution system through the AP. And we call the connecting network in this way as the infrastructure network. As you can see here, wireless devices in ad hoc network mode are communicating with each other without a base station. For example, if we enter a war or went to North Korea, for example, then we will not have an infrastructure network that we can use. In that case, you will have to use an ad hoc network. If you need to communicate among the wireless devices, that soldiers use, for example. So, the way that terminals communicate with each other without having a central base station is called ad hoc network. There are two BSSs in this slide. An independent BSS, IBSS, is an ad hoc network that contains no access points, which means they cannot connect to any other basic service set. That is, devices in IBSS1 and devices in IBSS2 cannot communicate with each other. Let me explain the basic process of Wi-Fi operation. Actually, it is fairly simple. It usually takes several steps. You can turn the Wi-Fi interface on and off in your smartphone while sliding down the setting screen. If you turn it on, the Wi-Fi interface will start searching for a base station. These days, you will typically find many base stations wherever you go, as illustrated in an image on the right. It is the unique name of the base station called BSSID, which I explained earlier. By the way, if the base stations use the same radio frequencies, naturally the interference will occur, right? No doubt. For example, if you turn on several radios at the same time, you will not be able to hear any sound properly. So the base station do not use the same frequency. It divides into things called channels to use differently. Just as we have TV channels, and they are different. Wi-Fi is divided into channels by setting slightly different frequencies. You might not know which channel having to use if you turn on the Wi-Fi interface card on your smartphone first. You will start to search a channel because you don't know which base station would be used for that channel. In this case, we call it channel scanning. So we will get information such as what base station it is, or about the signal intensity, and so on, while we are looking up for one by one. This is called beacon. Beacon frame is one of the management frames in IEEE 802.11 based wireless LANs. It contains all the information about the network. Beacon frames are transferred or transmitted periodically to announce the presence of a wireless LAN. Beacon frames are transmitted by the access point in an infrastructure basic service set, or BSS. A Wi-Fi device can use one of two ways to scan available channels, active and passive. During an active scan, the client radio transmits a probe request and listens for a probe response from an AP. With a passive scan, the client radio listens to each channel for beacons sent periodically by an access point. Base stations send a signal called beacon at regular time intervals. This beacon contains useful information about the base station, such as timestamp, beacon interval, SSID, the channel number, and capability information, and so on. You could get this information. After finding and selecting an access point, I wish to communicate with the next step required is authentication and association. Authentication involves checking whether the mobile device has the right to use the base station or not. Password checking is the most popular method of authentication. Once the authentication is performed successfully, the final procedure is the association. Mobile devices can associate or register with an AP router to gain full access to the network. Association allows the AP to record each mobile device so that frames are properly delivered. Association only occurs on wireless infrastructure networks, not in ad hoc mode. A station can only associate with one AP at a time. After this, data transfer can happen. There are many Wi-Fi APs on the market today. In fact, various APs use different Wi-Fi standards. I told you that 802.11 is a set of Wi-Fi standards. Because there are many standards people have added alphabet letter after 11 to distinguish them. When the standard first came out in 1997, it did not have a suffix of alphabet after the standard number. People call it the 802.11 legacy standard. Then came B and A and G were added. Next, N was added. Recently, AC has been added. Other standards are still being developed. The difference is that the ISM band has two bands I mentioned earlier. The first one used 2.4 gigahertz without using 5 gigahertz. Because people wanted to use 5 gigahertz as well, thus the products that use 5 gigahertz band became available. ODFM is used as a transmission method in IEEE 802.11 N, and AC. OFDM is a frequency division multiplexing scheme used as a digital multi-carrier modulation method. A large number of closely spaced orthogonal subcarrier signals are used to carry data on several parallel data streams or channels. The antennas are divided into SISO and MIMO, depending on whether one antenna or multiple antennas is used. Therefore, if the device has more antennas, it will be able to send data further distance, and data transmission speed will get faster. Consequently, the process of sending more data in less time by combining various antenna technologies and transmission technology is the parameter of the channel bandwidth. As you can see, the alphabet letter became to use letter of alphabet, such as it goes to A, G, N, and AC. That means you can send more data at the same time. So if you look at the maximum transmission rate on the bottom of the slide, you can see that there is a huge difference. IEEE 802.11n is probably the most widely used product because several years ago, 802.11ac became a standard. Most of the latest smartphones or Wi-Fi products that are being released today include the 802.11ac technology. But 802.11n is still being used a lot these days. The difference is that how much data will be sent in a shorter time.